You guys? All right, so next up we have DDoS, sorry, there's a remote. DDoS Technologies Evolving Frameworks. We have two gentlemen from Prolexic who have some interesting insight and some data that I don't think any of us have actually seen before.
Let's go.
Oh, that's right, you're doing, 1 second, guys.
What are the complicated ones?
Yep.
Hello, everyone. I want to thank NANOG, first of all, for giving us the opportunity to talk a little bit about our specialization here in DDoS. We're going to go over some statistical, some stats related to what we're seeing as far as DDoS campaigns. We're also going to cover a couple case studies of actual campaigns and the frameworks that are behind that. So as we all know, DDoS has evolved somewhat. Oh, is it?
They can't hear you on the webcast.
Oh, they can? Hello.
You hear us in the back?
So, yeah, as we all know here, DDoS has become a little bit more of a nuisance and has gained, some popularity as primary forms of attacks. So we're going to go over some of the stuff behind this that we see, Prolexic, what we've covered. In this first slide here, essentially, this is covered in what we publish a quarterly global attack report. Over here on the left side, we classify as infrastructure attacks, or layer 3, layer 4, and on the right side in green are our application layer attacks, or layer 7. This is based on the last quarter, Q1 2013, and there's been some changes and there hasn't been. Primarily, in first place over, we have SYN floods. They represent basically over 25% of all attacks that we've seen within our infrastructure. The cool thing about the way SYN floods in general are evolving is, typically you have, basically spoofed attacks utilizing anti-spoofing mechanisms. However, we've been able to correlate actual literal campaigns that are not using spoofed. So fingerprinting these types of attack vectors as they're running in TCP is, more of a primary gesture, that you want to cover within your institution. And number two, we have UDP attacks, covering over 16%, and ICMP. Those have maintained some standardization as well. On the application layer side, we have our HTTP GET floods. That is by far the most popular. Its purpose is very different from your big, bulky saturation floods against ISP infrastructures. These are typical attacks that can bypass IDS mechanisms upstream, very low bandwidth, and its target is web farm infrastructure, concurrent connections. This one, in general, application layer attacks are usually the tricky ones. They're also used in combination with other types of criminal activity, like fraudulent activities and stuff like that. So in DDoS in general, there is a little bit of overlay where you'll utilize it as kind of a smoke screen, which is important too. You allocate a lot of resources towards that. Don't concentrate on the real intention of the malicious actors behind specific attacks themselves. The one measure here that we've noticed, and Terrence and myself will be covering this, is the increase of DNS attacks. Right now in this last particular quarter, they account for 7% of all the types of attacks, and there's a direct correlation with that and reflection attacks, which we'll be discussing as well, as becoming more of kind of the norm on the framework of DDoS activity. In this slide, there's two slides here that we cover that we included within the global attack report. We basically wanted to measure, consistent rates of, what are your average bandwidth and packet per second rates. In this particular graph, you'll notice that, on the left side, anything from 1 gigabit per second underneath and the percentage of attacks within that quarter. And on the right side, you'll see 60 gigabits per second or greater. We've had a few of over 100 gigabits attacks last quarter as well. What's kind of impressive here is, well, on the left side, this is directly related. Well, there's two markers here, which is enterprise is not the only institutions that these campaigns are about. We deal with a lot of middle market as well. So there is a gigabit or 2 gigabits per second could really be devastating for a lot of institutions. And then more importantly, that also constitutes the fact that these are not saturation layer attacks. These are actual application layer attacks. One popular toolkit that we'll be covering, and in greater detail Terrence will be covering, it's called Dirt Jumper, is it's become a popular framework and their tool set that are used by malicious actors. And this one is the more impressive slide because a lot of kind of the hype behind attacks is always about bandwidth. But actually, the more impressive marker in malicious actors behind these types of attacks are packets per second. Over 22% of the attacks that we saw last quarter were 20 million packets per second or greater. That is crucial. This is like core router, border router infrastructures, sincere collateral damage, basically POCing and benchmarking border routers, which we all know can be weaknesses when it comes to packets per second, which include a lot of other aspects as well that could be a little traumatizing to institutions. So this next slide over here basically represents we have two data sets, but in Prolexic, this represents top 10 sourcing countries of malicious traffic that we have seen. These are all non-spoofed IP addresses, and here you see your map. China, still is on top, even though we'll see a comparison between 3 different time verticals that actually see a decrease in that, but also is, we're growing as an institution. So we're growing as a company, and the more that we grow, the better view we find on DDoS, and it's really impressive and dangerous at the same time on how globally scoped botnets are being created and sourcing attack traffic. One inclusion within this set here that we've never actually seen in the top 10 is the inclusion of Iran, which actually accumulated for over 5% of source malicious traffic. Another number within here that we like to bring up, even though it's still kind of it's an evolving kind of like centering point of botnet traffic, but Brazil's included within that. However, there are 5 countries that we've noticed from the top 20 of all maliciously sourced traffic in South America. So more and more we're seeing a lot more malicious activity, and more importantly, now we're seeing certain governments and these institutions in South America really beginning to sincerely consider the fact that there has to be some security upgrades within their infrastructure. So here, this is essentially just a comparison. We have this last quarter, Q1 2013, the previous quarter, and the quarter before. One to point out here is the flip-flop of the United States. One framework that we'll be discussing a little bit here is called BRODOS, previously named It's Okay, No Problem, Bro. That's where all the headlines are coming from for financial institutions and somewhat. There have been 4 or 5 official phases of the framework itself and botnet infection models, upgrades throughout this. That one period, United States, went down from almost 20% to about 2.71%. And, that was basically, about, community efforts, sanitizing. Our particular unit, we also work with other organizations, government, and private sectors to improve and clean up the internet, essentially. So this particular framework, does take advantage of the well-known vulnerabilities within web servers. So reaching out to that, validating that, and actually cleaning and sanitizing these machines is definitely a priority to all of us here in this room. So at Prolexic, this particular graph here, we basically broke down the malicious actors group classification. So we broke it down to 3 major types of sectors. So previously, we both have been in this market for a while now, several years, 4 or 5 years actively within DDoS, and sees its resurgence and popularity. Your script kiddies, your low sec guys, your early anonymous days, those types of people. Those used to be the norm, okay? Now we're moving into another where the norm is starting to become your criminal enterprise. This is basically exactly as it says here, 9-to-5 job. These are fully funded, just clock in, clock out at campaigns, very specific, depending on motives against certain targets and industry verticals. And then you have your veteran criminals. This is the smallest scope within the graph, but this is by far the most highly funded, massive botnets, attack vectors. I mean, we're talking about not only exceeding 100 gigabits per second, but it's the style at which they do that. Not only building the botnets, it's the attack types, the vectors. We've had, over 20 different targets, 4 or 5 different types of attacks. There's reconnaissance, there's a probing area to finding actual critical, areas where they can attack. And these attacks are typically exceeds over 50 gigabits per second. I'm going to go ahead and pass the mic over to Sir Terrence, and he will cover one of the popular attack toolkits here.
So this, thanks, Brian. So this toolkit is pretty weak on the global scale of things. It's not an amazing toolkit. It uses a typical C2 command and control architecture where infected Windows hosts will call back to an HTTP server to receive the commands for attack. Now, what's interesting about this kit is it kind of just comes up and goes down in popularity. So in the beginning, we kind of saw the enterprise criminals running this toolkit to attack different competitor websites. And then last year we saw kind of a change, and we saw that this toolkit was using to attack FIs. So FIs were financial institutions. Were like, what's going on? Why is this toolkit being used to attack us? So we released some paperwork and some documentation on it. As you can see here, it's leaked out to the internet, so everyone can download it for free and use it. Generally, they're using Dirt Jumper 5 now. This is 3, and it's very powerful for a Windows botnet, but it's not going to give you that high bandwidth. But it still will cause complications to right now smaller financial institutions. Just recently, we worked a case where a financial institution was attacked. They had their network architecture kind of misconfigured so that when their website was getting attacked, actually their LAN traffic was affected. So here's kind of a run through of what the attacker would see as he's kind of running through issuing an attack to these different organizations. So you start out here, and if you just hit the page, it comes up with a 404. It's a fake 404. You can kind of identify it through different MD5s, and you can even track different versions via the MD5 of the response if you cut out a section of it. If you enter in, the admin.php with the proper URI header, you get a login page. And for this one, it's set up to just admin, which is the default from the leak kit. So here, we can log in, admin password. Pretty slick security setup over here. It might be admin, I don't know, one of the two. It's password. So this is what they see. It's very simple. The Russian toolkits generally are pretty simple like this. They don't like to have these fancy kits. There's some funny talk, like in the forums about how they don't care about images and stuff like that. So you just enter in the URLs and then the type of attack you'd like to run. And for this one, he's got 4 different attack types. In V5, they added another one, which is an anti-DDoS feature, but it's actually not included in the binary, so it goes out to a function in the program that's not set up, so it'll just crash your bot. Now, what was popular about this one was that it was effective in the way that it handled resources better than the previous popular kit, which was Optima or Darkness. It was capable of generating very fast application attacks from a Windows host. It's written in Delphi, like most of the Russian toolkits as far as the binary is concerned. But on the grand scheme of things, it's not very powerful. For the C2 perspective, yes, but when you're looking at the different botnet architectures for what's better or what's worse, we definitely would see larger attacks in in kind of like the booter shells or the stressors as they're called. So here, if you were interested in actually querying this botnet, the C2 to see who you're attacking, you can hit this image.gif file, and you'll actually see the instruction come back, which is on the page here, 0420.120, info street DDoS me. So he's saying post flood, run 20 threads of the binary on the file, and then call back every 120 seconds, targeting this URL. So I'm going to let David kind of run into a little bit of the BOTNETs campaigns, which is those booter shells and the stressors that we were talking about.
Yeah, it's a 30-minute slot. So I apologize if I run a little bit quicker on some of the slides. I just want T to get into some of the later work that we were working on a particular case. So this is BOTNETs. This is an actual campaign that we had against an enterprise organization. We did a case study on this. This is pretty sincere. I'll show you the next slide, which is some of the attack attributes behind them. It was cool. Well, in one section here, we basically have maliciously sourced through our DCs, geographically located, so you can see how the malicious traffic is actually traversing into our network. About a little over 75 gigabits per second just in Europe alone. And this attack campaign right here had 3 different attack vectors: SYN flood, UDP flood, DNS flood. Accounted for over 130 gigabits per second, over 94 million packets per second. Some destination ports related to the attack types that are utilized within this particular campaign. Some of the campaign characteristics included what we were able to validate within the botnets included over 1,000 compromised web servers. These are majority of machines I had mentioned before. The most popular forms of infections for these machines are utilizing WordPress and Joomla. Please patch your servers. Eval scripts, which is a method of actually running it, which is the attacks are executed in memory. Therefore, it makes it a lot harder to track basic logging mechanisms within that. This second campaign I'd just like to bring up was, it's another attack that was specific to BOTNETs itself. Not nearly as big, but the geo map. So we first were tracking this botnet in November of 2011. Highly concentrated inside infection, highly concentrated inside of Eastern Europe. These are all newly identified participants, so we maintain an update based on this botnet activity and all the campaigns we've seen on the source IPs validated, which are actual web servers, maximizing on a lot of bandwidth, on hosting providers, bulletproof networks, and so forth. Originally it was like that, but now you see a clear picture of how distributed this botnet is, and the infections, and the concentration in the United States itself, which wasn't the case before. So there's a lot of movements, and inside of DDoS, it's not just about mitigating, this is the other side as well, and the infection process and the botnet and the way it builds and the framework in which it runs is important to actually understand as well. These were all non-spoofed, obviously, as we talked about before, and we're all fingerprinted essentially through detection systems that we have, particular to this framework, the attack scripts that are utilized within that. I'm going to start it off this quick slide and then pass it on to Terrence. So essentially, booter scripts, DDoS, denial of service. This is also a very popular form of attacking methods. Essentially, BOTNETs is a sophisticated version of booter scripts. It's just a suite of booter scripts. Booter scripts have been going around for a while. IRC-based, the basic framework is a hybrid of C2. It's not actually that, as you mentioned there, some instructions are pushed, others are pulled. DDoS for hire, even though it's been around forever, is gaining popularity as well. Some of them are free, some are from sales, the underground market. It's very, very cheap to lease a botnet and to launch an attack on an enterprise institution. Extremely cheap. It's copy and paste. Even though PHP and particular BOTNETs and booter scripts, PHP is the most popular form, but as listed here, and we've been able to validate, and Terrence will elaborate on some popular booter scripts. You could also use other types like ASP, Perl, other scripting language are utilized within booter suites as well.
All right, so booter shells, the stressors, these are kind of the new wave and movement that we're seeing. move into denial of service. When you look at denial of service and you look at HTTP and networking, like from an applications perspective, there's two real services, or there's two actual like applications that are really highly tuned for this, right? You've got your web server, which is tuned for handling large amounts of web requests, then you've got the web browser. So currently, what they're using is the web server with the booter shells and sometimes C applications to kind of mix this up to generate these large amounts of attacks. And they're utilizing them in a specific way that is allowing them to create very large and very high packets per second and requests per second traffic based off of these two methods. So there's a couple ways of doing this from an application perspective when you're looking at the server. There's two right here. One is, this is kind of the older way. This is still kind of popularly used, especially with like kind of the script kiddie market, like kind of right before script kiddie enterprise terminal, is they'll basically drop these PHP applications that use an IRC backend for control. So it could be a number of things. It could just be a single PHP script that will connect back to the IRC server, receive instructions back, or it could be slightly more complicated, where they'll actually have kind of a suite of tools on the box to gain root access for spoofing traffic, as well as different C applications for generating higher rates of traffic rather than just using PHP or spawning threads that way. So this particular one is not extremely popular, but we chose it because of its style and its technique. It's included in one of our thread advisories on booter shells, which released about a year and a half ago. So again, kind of like not a very popular method, but it is it's kind of popular in Asia, is through ASP. So these booter shells, these booter suites are not just limited to PHP applications, even though generally your PHP applications are going to be a little bit more insecure for different types of like RFIs than your ASP applications. So this one here, same method, file can be dropped probably through like an uploader or something like that. They'll launch it, they'll hit it with some URI options, and then start a get flood against a web server. Again, very easy to mitigate, but when you're compromising large amounts of machines, specific to regions, you can cause a lot of damage through these methods. So we're going to kind of switch gears right now and kind of talk about one of the other things that we're seeing a very big uptick in, and it's reflection. We've started a whole white paper series on reflection attacks. We kind of want to do this to talk to the community about things that we're seeing that should be fixed 10 years ago. One of the last ones we just released was talking about printers and routers being used, and we specifically wanted to talk about chargen, which, I mean, chargen should be deprecated from the internet. In 1996 there was a CERT advisory about how it should be turned off, but we're still seeing chargen attacks. We're also seeing SNMP get bulk requests being used for different types of reflection attacks. Those are still very popular. You can get some really high rates of traffic. One of the things that we found when we were doing the research on that was that we could say for requesting a specific MIB, if we were requesting the description MIB, we could request a description MIB 100 times in a single request and get back a response that said, okay, this MIB is going to respond back 100 times. And that gave us about a 7-to-1 reflection. Then the other one is NTP, is another very popular service that is used in these reflection attacks, kind of the odd walls, right? Besides DNS, as everyone always talks about. And that one we were able to gain some really neat amplification rates. We had about a 1 to 47 rate in amplification due to the NTP mon list. And we had actually seen that targeting a specific customer kind of in the gambling vertical consistently over time for about a year. And basically, all they're going to do is go out and enumerate these NTP servers and then get this reflection. We released tools to kind of test this and gauge the rates of reflection on the amplification. They don't allow for sourcing, so you can't do anything malicious with them. They're on our GitHub at github.plxsert.com or /plxsert. And then, the popular one. The popular one, of course, is DNS Reflection. I kind of want to talk a little bit about terminology here. So we classify the attacker as the malicious actor. He's the source that's spoofing all the traffic. And then we've got our victims and then our primary targets. So you can kind of see here we have our attacker, we've got our victim name server or name servers, and then we have our primary target. And, to campaigns, the primary target could actually be the victims itself or the primary target itself, but this makes it easier for kind of explaining it or talking to customers when you're saying, okay, you're under a DNS reflection attack, you're the victim, they're using you as a reflector or a mirror, or you're the primary target where they're actually, testing traffic to you. So in 2012, the largest one we saw was 42 gigs. It was definitely a third of what we saw to the DDoS campaigns or the stressor scripts, but it was still admirable. I mean, 42 gigabit per second attack can take down a lot of infrastructures, One of the neat things with DNS reflection, if used properly, is, you have a DNS flood, you have a UDP flood, essentially, and then you've got a UDP fragment flood, and then all the servers that you're querying that aren't online again, or, your tools are messed up, you're getting an ICMP flood. And then, the attackers will like to throw in things like the kitchen sink and then throw like a get flood at you as well during these specific campaigns, which was highlighted here. Now, recently, we talked about a DNS reflection attack that was 167 gigs to our infrastructure. And I got the graphs right here to prove it. This one was interesting. We've seen this before. They used a text or an any request. We don't have access. This happened Memorial Day, so haven't seen the request yet. But if you look here, it's very small, but you can see the cursor here. So up here you've got the question, and then down over here you've got the response. So the response was like 3,900 bytes, and it was just random text data, kind of in a little bit of a sequence where they copied and pasted it, and they reflected the traffic off of this. Now, this was very effective. I don't know if they compromised the server or not, or if they just kind of found it through their querying of DNS servers on the net. But we've reached out to the specific site that is t4.debrel.com, which is like a camping site in Amsterdam or something like that. And we were able to identify 784 hosts through NetFlow. We sample at 1 to 1,000, so we weren't able to get, the 37,000 hosts that, these people are posting these lists. But 763 of those had recursion enabled. So this has been kind of a big push for us to kind of clean up the net. Every time we get these large campaigns, we'll go out, we'll capture all the IPs, we'll publish them to different security lists and different certs to get this stuff cleaned up. Because, even though we're in the business of DDoS mitigation, we're not in the business of causing problems on the internet. So the best thing we can do is get this information out to people and share it. So this was the graphs. They're really small, but we took about 90 gigs actually in one data center for this DNS reflection, and that was through London, pretty much because we have our best peering over there. The distribution of the botnet was heavily concentrated in the United States again, and if the targets are in the US, the attackers will prefer to actually use hosts in the US. And this is kind of that distribution graph. Like I said, heavily concentrated in the US and then as well as in Asia. So we also queried the hosts for different versions to see what they were running, bind on top. But Microsoft came in a pretty distant second, which was interesting. Also, Power DNS recursor, DNS masquerading. There's some fun ones here. They had their version set to a smiley face. Some guy was talking about a doctor's license over here, and then just nope. So the other thing we did with these hosts was some of them had SNMP open. So we wanted to graph it and see what one of these servers actually looks like on the net as far as bandwidth is concerned. So we ran it, just a small sample set, just on 2 of the servers. We just ran an SNMP get for their interface statistics and their incoming and outgoing bandwidth and packets per second. And what we saw was nothing crazy. I mean, one of these hosts wasn't putting out 100 megs, although actually, well, this one was. He wasn't putting out like gigabits of traffic. But the reflections weren't really there kind of in the numbers that we saw. So, if you see here on the top one, this was probably, this server was probably limited in bandwidth into what he was taking. And then on the bottom one, this is kind of what I expected to see from DNS reflection or amplification as far as what the actual server was receiving inbound and outbound. But, really, his outgoing max was 104 megabits per second, and his incoming max was 100. So these servers aren't, the sample set has to be larger. We have to look at this from a larger perspective, but I'm really curious to see, if they're really getting the amplification that, we're able to get in the labs kind of in the real world. So that concludes our presentation. I'd like to take any questions if anyone has any.
Hi, Phil Rosenthal from IS Prime. So we also obviously see DDoS attacks on our network, and the nature of the attacks over the past few years has certainly changed a lot. We actually are getting attacks much less frequently, but when we get them, they are, more sophisticated, larger. I assume you're seeing similar patterns, but that's not my question. But what is actually my question is, we've recently seen a trend where the attacks are actually dynamic in nature, where, say the attack comes in very small, the customer isn't filtered, they get, say, a gigabit of attack, it takes out their server, the attack goes away. The server, recovers, the attack comes back. We apply a filter, and, the upstream is now 10 gigs, the attack increases to 10 gigs. Takes it down, we move the filter further back, and the attack, then gets larger. And, then at that point, we have a lot more capacity to it, and eventually a few days later they give up and it goes away. Is that similar to what you guys are seeing as well now?
I wouldn't say recent. I mean, we've seen that for many years. Specifically, we first saw it in kind of the gambling market. Can you talk kind of to what region your customer base was in on that one, or? Because it kind of, so we see that to a couple different regions.
Oh, I mean, our customers are kind of whatever.
Global,
So,
okay.
Yeah.
So we've seen that, definitely with the higher class of criminals, that we'll call them. We first saw it out of Asia, where a lot of the attacks are being, sourced from there or started to be sourced from there. And then recently we've seen that out of the Middle East with the recent attacks to the different financial institutions.
All right, thanks.
Yep.
Eric Osterwalder. I was wondering if you guys could give a little insight into some of your mitigation strategies. Like, do you guys do scrubbing or do anything more like you flow spec ACLs, that kind of stuff?
I mean, essentially, our proprietary techniques, obviously we can't disclose, but from the graphs before, so we have 4 global scrubbing centers, and essentially they're just cleansing from malicious to production traffic. We just, depending on the particular type of attack, we have different mitigation controls in place to mitigate against that attack, simply cleanse it, and then release the production traffic. So, it's not just about mitigation, but it's also about false positive rates. So we try to stay as, on top of fingerprinting and evaluating that, and, not concentrate so much more on like black holing, rate limiting type of technique itself. And then the human intervention has something to do with it as well. Just like the previous gentleman's question, these attacks are dynamic based on operations that are existing. So it's essentially as if you're playing chess. They're working 24/7, we're working 24/7. Unfortunately, there is not automated technologies that are actually dynamically learning and validating, those types of things. So there's a lot of human intervention involved, both in the attacking side and the mitigation side.
Yeah, and one thing I'll add too, and when it comes to DDoS mitigation, sometimes simple is better. Not enforcing every single policy, but enforcing the one that will actually mitigate the attack will let your gear work harder at mitigating the DDoS attacks and not focusing on everything else. So that is one thing that, from a network perspective or an IDS perspective or a mitigation device perspective, that's one thing I think we do really well.
So yeah, that last part, if I could just follow up real quick. So did you find any of these tools any more or less sort of useful in different scenarios, or is it kind of like what you're saying? It's like different attacks call for different strategies, or in the remediation. I don't want to dig out special sauce. I just wonder if you give us a sense.
No, yeah, that's totally cool. It's based on attack type and the vector in which they're attacking is security controls are in place for those. So certain, an SSL post-flood is going to require a different mitigation strategy than, say, a UDP flood. So, it's understanding all the different attack types and vectors in which they're, and Terrence is right, less is more in a lot of ways. Over mitigating, layer on security controls, actually create more false positives. Fingerprinting and dealing with what's in front of you, and don't worry about the rest, is probably your best strategy.
Thank you.
Jake McClure from Dyn. What are the top 3 categories that you see get attacked? You specifically said gambling. I'm curious what else.
So you're talking about industry verticals?
Yeah, and yeah.
Yeah, I mean, it depends on the time of year. It depends on a lot of things. It depends on what's going on at that time. I
Okay.
mean, currently, I don't have those numbers off the top of my head. I can go look them up for you.
Do you release that as part of the report?
Yeah.
No, not necessarily. I mean, we highlight particular verticals and case studies, but not necessarily encompass, okay, blank percentages is for e-commerce, blank percentages for that. But you will see like, some of the PR stuff, but also like the report stuff, like specific to, if we see like a certain rise in a particular industry, we'll actually do a case on it and we'll release it that way. But we do kind of encompass many different verticals, and we're a global company.
Right.
So we, the more we see, the more we realize DDoS is everywhere in every vertical. I mean, whatever the press wants to write about is cool, but in our world, it's all the same.
If you've got a specific question about a specific industry, just reach out to us.
Sure,
I'll see what I
sure.
can do for you.
If you
Yeah.
consider it for your future reports, it'd be pretty interesting not only to know the percentage by category, but the timeliness of it, depending upon when in the year it is.
Yeah, so we did that one quarter in Q4, kind of like the Christmas time, to kind of show how the attacks will increase for e-commerce sites, during the holiday season. Just basically like competitor warfare. Just hey, I want to take you down so I can sell more flowers or whatever you want to do. We have a large customer base that sometimes is not very specific to a particular industry. So
Sure.
like we'll protect an ISP at some point, sometimes like smaller ISPs. So there'll be a bunch of industry verticals across that where it kind of will be a little bit difficult, but we'll work out some numbers and see what I can get for you.
That'd be awesome. Thank you.
Yeah, cool.
Thanks, guys.
Thank you. Enjoy New Orleans.